everyone. Welcome back to PyData Global 2024. I'd like to welcome Nompumelelo Mtsweni with her tutorial, 3D Geospatial Data Visualization using Python and CesiumJS. Thank you so much for this. I'll let you take over from here.
Thanks, Stephen. Hi, everyone. Thank you so much for joining this session. I'm joining you from London. I welcome you from wherever you're joining me at. My name is Nompumelelo. Most people call me Lelo. I will be taking you through a 90-minute tutorial session where we will be mapping in 3D using Cesium and processing our data using Python. So we'll start with the processing, obviously, and then bringing it all into visualization using Cesium and a couple of few basic web frameworks. Yeah, so to get started, I will share my screen. I'll share the entire screen. I hope you can see my screen. Let me just start the slideshow. So I've done the intro. We'll be using Python and Cesium for visualization. So I'll give you a bit of an introduction of what exactly are we going to do with these two stacks, what are we going to build. And then we will go over to our notebook, Jupyter notebook on the cloud. Using Python, we'll process some data. And then for visualization, because we're using CesiumJS, it should be JS here. I forgot the JS, sorry about that. You should have an API key. So I will take you quickly through the process of creating an API key. And then finally, we will write a bit of code on, the code is already written. We'll just go through the code, put in the API key and the geospatial data, and then have our visualization. And then if there's still time, deploy. So I hope out of this tutorial session, you will be able to get a better understanding of visualizing 3D data instead of 2D, and understand how Python can be used for processing such geospatial data, and then just have a basic experience with geospatial mapping in CesiumJS, and just finally deploying the visualization. So the audience is probably somebody who's still new into 3D mapping and maybe visualizations or just using Jupyter Notebook, as I consider this tutorial very, very basic. So geospatial data visualization, this is just a bit of an introduction, to kick us off really, because I don't want to assume everybody knows enough about 3D geospatial visualization. So I'll just have a bit of an introduction of what exactly is it. So 3D really, it is just data that can be presented in a coordinate system that is beyond the normal X and Y. So there's a Z coordinate, which just adds an element of spatial and perspective to your data. In the context of geospatial, it just adds an elevation or a depth, depending on what type of geospatial data you have. So geo has to do with the Earth. So we're talking about 3D data in the context of the Earth's surfaces. So basically anything that you can think of that has a location element to it forms part of this geospatial data. So the reason why I like to use it, or maybe why is it important, it's because it's one of the closest sort of visualizations to reality. The depth element adds that point or that feature, unlike 2D where it feels like it's on screen, where it could be on your device or any type of device. This 3D geospatial visualization tends to be a representation that is almost accurately representing real-world scenarios or situations. And it's just, I think it adds an advantage to sort of work with 3D geospatial data as opposed to 2D, just because of how close it is to the real world scenarios, or just the spatial understandingness of the data itself. So it allows for better simulations in most cases, or like more better predictive simulations. And it is often useful in fields that are focused with the Earth surfaces a lot. So those could be in construction or maybe mine engineering or urban planning and the likes. So it might seem cool to some, like in my day-to-day work where we're looking at it from an immersive side of things, but the 3D geospatial on its own is an important type of data to work with. It's so important such that, let me just show you this story. So it's so much so important that it goes beyond fields like construction that I've spoke about, or urban planning. It's so important that even fields like journalism can even apply it. Allow me to share this story so quickly before we get into our hands-on tutorial session. So this story is a preview of a project I've worked on recently back home in South Africa, where an investigation is currently underway about a murder of a woman. So it's a very emotional story and it's very comprehensively told in here. I'm just going to draw you back to the element of where geospatial was used. So the journalists, they wrote a lot about the events where this woman was found and the suspect was found at. But I'm bringing you this part here where I've worked on, which is mapping, not on Cesium. This time around, it was based on Mapbox. So here, 3D geospatial data was used for storytelling, and we're mapping events just before an incident took place, a vital incident took place. So it's a scrolly-telling approach, as you can see. And so I was scrolling from one point to the next. We get an element of time, what happened, an event, and a really specific location. So it's an outdoor mapping system.
Oh, hey, Lelo, were you trying to share your screen? It isn't visible anymore.
Oh, I'm sorry about that. What is on my screen at the moment?
Just you.
Oh, I'm really sorry about that. I'll try and reshare the entire screen. Not the window. I'm going to select share. Can you see a News 24 article with the pointer at Sunset Bay Center? Oh, you can see. Great, thanks. Sorry, I have to dip in and out, and sorry, it's my first time presenting, so I'm really sorry if I take long to look back in here. Yes, where was I? Talking about the importance of 3D geospatial mapping in the context of journalism or just storytelling. So yes, we mapped all of this data, and this data was captured by CCTV cameras. So now incidents took place, cameras captured, and then only later when the investigation was underway, we had this data and we had to somehow map and track and visualize it. And I mean, this is just one element of how useful 3D geospatial mapping can be used at. If you want to go and have a look at the story, this link is in the slides. Slides are in the resources tab. So that was one aspect of using a type of geospatial data in this story. There's a video here where there's 3D modeling. It's also just as important as well, where you represent an element in a 3D form. This is another video I've worked on. This one, it's a video, but underneath or the composition of it involves a lot of photogrammetry. So it's locating where the incident took place. I won't play all of it, and I'm gonna mute the sound. And then using After Effects and Premiere Pro together with the team at News 24 and the team at Delta Scan. Delta Scan is the company that use their drones to scan this area and capture the environment in different types of 3D models. So a lot of work went into this project. It's still underway. This is a 3D model of a park where the incident revolves around. This is another video, again, talking about what happened. But the most important one I want to bring you on to is this one here. So far we talked about, the story has shown a bit of 3D models, mapping in 3D. What it hasn't shown us is these Gaussian splats, which is another form of visualization that is very common these days. It's making waves a lot in some tech domains than others. So the team were trying to bring it onto immersive storytelling in here, pointing cell tower where it was at in a form of a video. And there's just a lot. There's a lot of 3D elements that were used in here in this story to just try and bring the user, no, not the user, the reader, to understand how the incidents have took place. It's such a situation that happened. So these are the companies that were involved in production. I was contracted by Delta Scan. That was just one project. I thought it would be nice to mention. It involves 3D geospatial mapping, and that's what we're talking about now. So back to us and this 90-minute long tutorial session. What will we be building? I don't know if you can see, really, it's not a video. I wanted to make a video, but I ran out of time. This is London. It's a part of London. This is at King's Cross. These lines, underground tubes. Yes, they're underground, but I have them overground. So I don't mean that these are overground tubes.
You're sorry, your video is in, your screen isn't visible.
Again?
Yeah.
Oh my. Maybe it's some settings I should have done, I should have gone through. I'll do this. I'll share by window instead of sharing the whole screen. Maybe that could help. And I'll try not to jump from one window to the next. My apologies about that. Let me see. Where were we? This is a window, right? I want to share. Oh man, it's gonna be hard because I'm hopping from Python to other windows. Fine, let's stick to this one for now. Okay, can you see a picture of what we should have as an outcome or an output of this tutorial? It's just a screenshot of some 3D buildings and a Cesium logo and some colorful lines. Can you see that?
Yes. What we are going to build?
Oh, sorry. Can you? Okay, so you can see that. Right. So we will process a bit of these transport data so we can be able to see the tubes, and then I didn't have enough time to have custom-made models or to find a more reliable way of bringing in 3D tiles of these buildings. So I'm going to use the default one that comes with the Cesium's API. So it's hosted in the Cesium Ion. And then that very same data has metadata about it. So when you click on some buildings, you will see information about the building level, what building ID it is, what type of a building it is. Some will probably tell you maybe, I don't know, start date. I can imagine I might be wrong here, but maybe the documentation explains it better. I'm just thinking maybe when that building was constructed. It's a thought, but I'm not so sure. But there's a lot of rich metadata from these tiles, and they come directly from Cesium. We will be able to search different places. I mean, obviously my data is limited to London, but it doesn't have to be. This Cesium Globe, this Cesium visualization tool is so powerful. It captures almost all areas in the world. There's different map tiles you can use. I'm just interested in the dark map tiles. That's why it's looking dark here at the bottom of my terrain, whereas there's many ways to customize this. We can change it. You can use different image renderer other than, not image renderer, but tile renderer. So instead of having CartoDB like what I have down here, we can have maybe one from OpenStreetMaps or from Bing. There lists many. Yes, that's what we're going to build. By the way, so in the slides I've mentioned, the person who inspired me to maybe build this project, I wasn't really sure what to bring in this time around for this 90-minute long tutorial. I had a lot of different ideas and I wanted to bring very different kind of data but I had some issues putting it together. This was the basic one I could and one I'm comfortable in teaching about. So this researcher, Stefan, I think he still is part of a research team at UCL in the geography department. So data comes from a report that they and his team have worked on, and on their visualization, it's just the lines, and it's not on Cesium, it's on Mapbox. But when you follow this link here, it'll just show you what they have. They don't have buildings, they don't have this type of globe, they have a different type of map renderer altogether. So how are we going to do this? So if my internet keeps dipping in and out, I'm really sorry. It just means my internet connection is unreliable. We will need a reliable internet connection, and then we'll need a Python Jupyter notebook. That registration for the Cesium Ion API key, we will have to have it, and just somewhere where you can fiddle with the code to visualize those data sets that we would have processed from the Jupyter notebook. So right now we get started. We will be using a Python cloud for processing the data, and then what else? Yeah, I guess I mentioned this part here that there could have been a way to use Cesium in the notebook itself, this Jupyter notebook here. Can you still see my screen? I feel like I've jumped out of the other screen and I'm worried that I shared with the window instead, so you might not see my screen. Yes, okay. Okay, you can still see. So can you see the Jupyter notebook? All right, I'm guessing, no, not the Jupyter. So you're still seeing, are you still seeing the what is this? The Google, the Google presentation.
Yeah, I'm seeing the part of your slides with the collab research.google link.
Cool. All right. Allow me to share again. Okay. Now I hope you can see the Jupyter notebook. It's hosted in online with the Google Colab. Can you see that one? Yes. Thank you so much. So we will take a break, maybe halfway through the project. So yeah, bear with me if I seem to be taking a bit long on other things than the others. I realize it can be a very hands-on project, so we will break a bit. Right, so to kick us off, if I don't know, I'm assuming everybody has worked on this environment. They know what this environment is. Some people have their Jupyter notebook installed locally. I'm one of them, but I thought for this purpose, let me just host it live up and run with it live. Right here, I'm importing a couple of packages that we will need. And this is the tube data, the underground London for transport tube data that we will be processing in here. So it's a GeoJSON file. That's why we have this JSON package that we need to process this data. Thank you for sharing that, Stephen. Then we will work a bit with GeoPandas, and then we'll have a few of these other packages as well. So I think after importing this data in here, like I mentioned before, this data comes from a team from UCL in their geography department. I didn't check which year, so it might be outdated or might not be, but if you follow the links and you follow their work, there's probably better documentation explaining the process of gathering the data, what they went through to get it to this point that I could use it in here. Although it isn't a final point, we're still gonna do a bit of work. So in the next line, we want to read this data. Right now, we're just, saying that, look, we would wanna get this, GeoJSON data that is hosted in some location here in our drive. And I think the reason why I have this error here, I still have the error. I don't have the error anymore. cool, I thought I had that error. It's because this is pre-processed data, pre-processed in our context. In their context, their pre-processed data could have looked very differently. For us, this is the pre-processed data that we are processing in here. And we're just in these functions asking, I mean, not even a function here, we're just asking to open this file using the JSON package. So this is that pre-processed file, and then we want to get a sense of what it is that's in this file that we are working with. Like I said, it's a GeoJSON file. It has these features in here, tells you about when these stations, so these are different underground stations in London, what type of geometry they are, the locations that they run from. It's a very long file. So far, I just took like the first 1,000 characters from it. And then I can see that from this file, I'd like to do some processing and mount some data into the local drive. So I run this command as well. The reason when you run it on yours, it might ask for permissions. Google Colab might ask for permissions that your drive will be mounted. So grant it. The reason it's not asking is because I've already granted it. And that's why. So we move on right now. We're looking at our data file. We're trying to segment, we're looking at the different features in our data. We're trying to work out what these underground lines have. So we go through every feature in this data structure that we have, this massive GeoJSON data file, and we're trying to segment if this one line or this one sort of a underground segment is shared or not. So this is when we're grouping the underground lines or tube lines that are being shared or that are not being shared. And then we're putting a conditional statement. If they are being shared, then this is what you need to return. It's true or false. Later, we will use it when we map with color coding to say, well, this is how we should be visualizing the data that is shared and the one that is not shared. So all I could find is tlf.json. TLF lines, not GeoJSON file. So TLF lines.json is a file inside GeoJSON folder. Let me maybe have a look at that. Am I wrong? Oh, wait. So okay. In the chat box, Christopher, could you please tell me where are you finding this JSON? Is it not a GeoJSON like mine here? I hope it is. Okay, I'm gonna pause it there. I mean, you're welcome to. No, we don't have access to your drive, but took a look at the GitHub. Oh, wow! I thought I've granted privileges to this drive. Hang on. So anyone with the link, it has to be an editor. I hope you can see my screen where I'm just granting access to everyone to be able to grab this. I'm gonna reshare this one more time. I cannot seem to remember when I changed the files. I might have played around with the names, but the file format has always been a geo.json. I'll look back in the GitHub repo, which, yeah, let me not go back to the GitHub repo. It's a pain to think about it. Where were we? Right, segmenting these lines. So, so we are continuing right now. We're looking at the properties on each line and their line names, and we're just looking at these different arrays that are grouped by the different lines, like tube lines. Sorry, when I say lines, just think of the tube lines that I'm talking about. And then in here, I'm assigning these to features. It's more like recreating a new data set from the current data. This is where the processing is happening. And so I'm saying for every feature in this newly created, I don't know what to call it, this new created structure of data, we could maybe just delete some of these properties that we do not want, or keep the ones that we do want, and then we have some error passing in here. It's not saving since then. I don't know, I hope it's not my internet. Right, so we go on. Okay, so let me see this one error here. There's another file that I don't have that I should be dumping into. So this is just like a file that I should have in the drive where we are dumping the pre-processed data on. I'm just gonna try and create it on the fly. Let me get this. Okay, let me just create it in here. Right, new file. So it is the London for transport, this TFL lines edited the GeoJSON. Okay, we have that in. So let's try one more time. Oh, right. The reason why is because my folder name, it was, for the longest time, it was static, and then I made it geo. Not too long ago, I called it GeoJSON data. See now. Okay. So we've successfully dumped the processed data from this pre-processed one into that one. And then again, we'll have this issue because I forgot to rename this one folder's name. I changed the name of the folder from static to it being GeoJSON just because before this Jupyter notebook had other data that it had other data that was irrelevant to this. Okay, so it cannot read this file. Okay, that's because I wasn't supposed to create it. I should just use the old file. I can't remember what it contained. I'm gonna upload the old file. Hang on with me here. Let me just see. Upload the file. It should be in the same data. It's here. Okay, the London file, the edited one. Okay, I thought this is where it was editing to. I'm only uploading this data just so. Okay, why do we still have this error? GeoJSON DLF edited. So, okay, what is it saying? There's no such file in the directory. DLF lines edited. Okay, I'm trying to see. .geojson, this is the file and it is in that directory. What am I saying? Data frames. Read and open that file. Why am I really having an issue with this file? Okay, obviously this command will not run without that one. Maybe, if it's okay, refresh and remount. Okay, thanks, it's a good suggestion. Let me go and just do that, refresh the page, and then I will, I was gonna ask me we take an early break, but let's just see how this one unfolds. Okay, where was I? Where were we? Sorry, not I, but together, we're together in this. Cool. Okay, so this we run, this command we run. Okay, this other command here we run. Okay, just rerunning every command here. Okay, that's one. Okay, see the dumping. Okay, there is no such file. This is because of this GeoJSON data. GeoJSON data, the full folder name is GeoJSON data. Okay, that seems to be now running. Okay, let's see this last command. Okay, again, it's the folder name. The GeoJSON data. Thank you. That seems to be working. Thanks a lot. So it's essential if people can mount their own drive. But thank you so much. Christopher, this helps. I think it helped. Well, it helped to get us where we are now. So we're just trying to get the top bit of this newly processed data, and then the rest of the stuff right here, it's not so relevant because it is speaking a lot about Mapbox, whereas we are talking about I think whereas we are talking about Cesium a lot. So some of the processing that was done here is relevant to Mapbox, whereas we will not be using it for Cesium.js. Okay, so it's fixing up some familiar lines here. Okay, it's about coloring, which we will do our visualizations in Cesium, so this is also not relevant. And then finally, we are trying to create a new file with all this pre-processed data in. Okay, wait. We're dumping this to a file called what? Choops.polygon.geojson. So it's GeoJSON, GeoJSON, data like that. Okay, so this file, I'm only adding it because, in case, I think I already have it here. It's a Polygon file. These are all the backups in case such things like this happen, and I can always just maybe go back to them. So our data processing is done. We had the raw transport for London data unprocessed. We process it in a way that we will be able to use it in Cesium for visualization. So we can download these 3 files, and if you have access to my GitHub repo, pull them and locate them in. Sorry, a lot of these windows are open here. So this is my GitHub repo. If you manage to pull it, and then create some, well, I'm guessing it's already created. This should be the data. The rest of this data in here, it's irrelevant, but it's still good GeoJSON data, which was used for a feature which we will not be handling in this hands-on tutorial. Sorry, is it okay if I ask for maybe, I know I said we'll probably take a break halfway through the session. It's not halfway through the session yet. Maybe I was fast, but how do people feel? Should we take a break right now before we jump into visualization, or should we go straight and visualize? Let me quickly go and see. Okay, maybe we should just continue. Okay. Thanks. Yeah, yes, there were a lot of typos. Thank you for this. This helped a lot. Because yes, there were a lot of typos in the notebook, because when I kept moving these data files and placing them in this new drive, I tend to forget to change the names. But yeah, that's enough about visualization. Maybe let's jump into Cesium, and then, sorry, enough about processing. Let's jump into Cesium for visualization. Oh man, sorry, it's towards the end of the day here. It's been a long one. Bear with me when I keep making these mistakes. I'm closing this window. We're leaving that in the GitHub repo. You should have this presentation, and then the visualization.zip. That's where the code is at. I'm currently facing an issue with GitHub where my old account, which used to be this one, is unrecoverable. So I don't know when was the last time I committed. On this new one, I have like an issue of just pushing from the CLI. So that's why I have stuff in zips, and I don't really like presenting them like that, but we're out of time. So have this zip installed, downloaded and localized. Now we're signing up for the Cesium account. If you already have a Cesium account, this part, maybe you can just, I don't know, not pay too much attention to it. But if you do not, then yeah, follow along with me. Sorry, I logged in very fast. So this is Cesium. It's a geospatial platform that we will be using to get an API key from, which will be used to visualize in the globe like this one. Sign in here if you already have an account. If you do not, you'll have to sign up here. In my case, I have an account. I'm going to sign in here using, let me just sign in using Google, because there's just a bunch of confusion with my GitHub accounts at the moment. Right. So I'm using it for personal use cases at the moment. I think when you want to use it for commercial purposes, you need to upgrade. For this tutorial, we're not doing commercial work. So I have a couple of assets in here. When you're starting out, you might not have much going on. I have a bit going on in here. And then this is where we want to come at. So one should create a token here for pretty much, I think, for this project in particular, yes, but it can depend on other projects, what kind of token you want. And what I mean by kind is the scope of the token, what should it be able to do and what should it not be able to do. I created a basic one for now. I just, I think I called it this, I called it Cesium Python, and I gave it all the access because I just I enabled everything. It was quickly to do that way. Thank you. Thanks for the link. So when you have this token and you've given access to all the scopes, just maybe copy it somewhere. And for now, you can leave the platform, but when you have time, there's a lot one can do in here. You can create stories. You can host your own assets, almost similar to what Sketchfab does. You've got your own 3D models and you would like to place them in here, you can do that. And they give you about 50 gigs of data to just store all of these assets. You can track how much you've used for what over time. So it's a very useful platform for visualizing geospatial data. Okay, we now assume everybody has signed up, and then we are going to go into the code. So Cesium has a lot of tech stacks that it is supported by, and it can be data visualized from it can be rendered in so many different ways using different platforms. We're sticking to web right now. Although if you've got VR, it's possible to use Cesium there. If you've got, I don't know, if you want it for mobile development, it's still very possible. I mean, Omniverse is there. It's very comprehensive. It's very rich. So we're just taking baby steps. Doing it basically at a very basic level with the web. So it's CesiumJS, and I'm not using any frameworks. I could have maybe used React. I could have used Vue. I could have used any framework I felt like using, but because the core of it was in the framework itself, it's just getting to use Cesium. So I just went straight and I used basic HTML, CSS, and JavaScript. And this is basic web development stuff. I just created a very basic HTML file in here to render this, to visualize this data. And then I'm styling it a bit. I'm creating a very basic C# styling here to just style these two buttons and the Cesium container itself. Cesium container is just like a viewer, this globe that we'll be using. And in my body section of this HTML file, this is when I'll be calling the Cesium container, this Cesium ID is the container here. It's the viewer itself. I just gave it a div with that ID. So if I needed more styling, it could go in there. Or I needed more control over, I don't know, making more behavior changes, not to the globe itself, but maybe adding more functions to it. That would be the ID to use. So these are my two buttons, and they get triggered when I click when I click them. How does this look locally? It looks this way because I think it's because all the data is already in here. And also because I have already populated everything. I wasn't sure the best approach. I wasn't sure which was going to be the best approach to build it bits by bits with everyone, but that could probably took a long time when I wouldn't know how to debug some of the bugs that could inevitably come in. So yeah, it's already built. So I'm just going to take you through it. This is a JavaScript file that we'll be spending a lot of time on. So you should have a folder called scripts, and in that folder, why do we have this index.html in this one? Oh, never mind. Sorry, I was reading wrong. Scripts has these two files. This we can get rid of. It has features that are not relevant, where I was just trying to grid and fly to different places. It's nice to play around with, but for this purpose, let's just stick to script.js. In script.js, the first thing we do is populate the API key, the token that we've gotten from Cesium. So here is mine. If we're going to go into production and we're doing very serious work, we're not learning, maybe if you're using like a framework, this will probably be some secret environment key somewhere. So you'd create some environment key and just call it a key and save it somewhere else where people will not see it. At the moment, it's very insecure. People can see it and maybe use it, especially if it isn't so restricted. But for this purpose, I didn't see the need to create environment variables and other stuff when all we want to do is just visualize transport for London data and some buildings. Right, so we're creating a variable, we're giving it a name, viewer, and this is that container I talked about in our index.html file. Where is that container again? This is it here. So I'm assigning some terrain to it because it's a globe. It needs a terrain. So this line is very mandatory. And depending on what you are planning to do with Cesium, there's a lot more that you can put in this object in here. There's a lot more of other properties that it has. So if you have enough interest to work with Cesium, go through their documentation, you'd be mind blown by all these rich features that are there. So here I'm just like playing with the little stuff. It's the tip of an iceberg. I'm just using one property and I'm calling that terrain. And then this is a viewer for the imagery that I want to use. So it's the reason I'm commenting it out is because I need us to see its importance. Over here, I commented out that line of code, and this is a local run. I'm running it locally. And by default, as you can see, I have this imagery map. If I bring it back, I'll have the dark map style that I've once mentioned so far, that I really, really like working with the dark maps. So now we should have this dark map style. So what is that line? What is that special about that line? Those few lines I was commenting out. It's a custom way of adding. It's a custom way of adding these imagery tiles that are not here by default. So there's a lot of these imagery map tiles that you can use. We spoiled for choice. If it's not loading, it just means the style is not added in my token, in my Ion drive. But the ones that will show are the ones that I do have. So I have these OpenStreetMaps which I could use, Bing maps that are very common. There's a lot to pick from. This is also one of my favorites as well, but it's not so dark. It's like olive. So I didn't really use it. So instead, I found a custom way of just bringing in the one map imagery that I really like. And this is just it. First line, I'm just removing whatever comes by default with the viewer, and then I'm adding my own one from this Kato database base maps PNG imagery database. So they have a lot of different map styles, like different base map tiles. And this is just one of them. it's from OpenStreetMap's provider. The provider is from there, but the map tile itself, it's Kato. So we have that. It's up to you if you want to use the same one as I'm using. If you like light maps, then just get rid of these few lines. Now, with our viewer, that globe, we want, when the map renders, we want to go to a specific location. You know, we want it to land somewhere and show us something. So this is where we tell it with our fly to function that, look, when you start, I need you to go to this location in here. And in there, I want these extra bits of elements. I need your camera to face a certain way. So all of these little, well, they're not little, but these properties, they are for this camera object. So you tell it how much of the pitch it should be at, how much of, I don't know, you could, there's a lot more of other elements you could include in here, rotations measured in different radians. But all it's doing essentially is when it's just loading this page, it's flying to the specific locations that I've placed in here. And in this case, it's someplace in London. It's King's Cross, one of my, well, it's just King's Cross, I think, like the area, but I was just trying to nail the station itself. I think it's an international station or just like a big national station. It's flying to it because, you know, that function made it fly there. If you're in another part of the world and you'd like for it to fly at your favorite spot, you just need to get the coordinates of where you want it to land at. And in here, substitute those values and plug it in here. So this one, I think it's just the level of closeness to this place you want it to zoom into. You can play around to see how much it will zoom in or out. So maybe let's see if I say some ridiculously big number. Oh, I thought there was a question. The screen was shaking a bit. Yeah, it's sending me somewhere simply because I played around with where I wanted the focus to be at. I found it, I can't remember how come could I be able to find that it's this value at where it should be set at. But yeah, it's that one. Yes, this grid, these polygons, I think maybe let's just do this. We have this imagery layer, this grid, this whole entire function, it correlates with this data grid in here. It's not part of our visualization, but basically it's when you want to measure certain areas within a certain amount of grid level. So in 1 meter's distance, how much or which buildings are there? This is what I was trying to do, but we could comment it out because it's not relevant to what we're trying to do. So in the whole of these lines, I was trying to build a width to just work out. It's going to be a bit messy. I should think the one that's the script that's on GitHub, it should probably not have these already. If it does, then please take them out. It's just, they're not useful for now, but it was just a grid that you can click on a cell and you will be able to see what cell number you're on the grid and which buildings are in there. The grid itself is not a data GeoJSON file. It was just a dynamically created visual just to map over the area. And that's how flexible Cesium is. It allows you to even have functions that can overlay on it and do anything you want it to do. I mean, it depends on your creativity and your technical capabilities of what you want to achieve with it. So, and we have this tooltip as well, and this one as well. So maybe I would ask you to, okay, placing randoms here. Okay, wow, it's a lot. It's a real lot. So these files from line 21 all the way up until line 223. I think you can comment them out. If you do want to use them, really what you need to do is just call in this grid, have on the HTML file some 2 buttons to call in these functions. I'm not doing that right now because they're in a very different location. They're not in London, they're in the US and it's fine. Let's just keep stuff to London. So back to where we were. After the viewer has landed, we now have our 3D map. We want to see buildings. We want to see buildings. We don't care about many things. That's like the first feature. We want us to show us the buildings. And this is this buildings show buildings button is defined in the index.html file that we looked at, where there is that on-click function that triggers this button. So there's like many ways to visualize this viewer itself. I don't have to see it as a globe. You know, I can, but I don't always have to see it as a globe, depending on what you want to see. So for an example, you want to see, I don't know, some dynamic data, some movement of cars, which is very possible with this animation tool in Cesium. You would probably not want to use a globe that's rounded like this, because then, and especially if it's a long distance, although it could be possible, but the visualization itself, it will just not render so nicely with all these curves and just the roundness. So I might probably just want to stick to a layout like this one, or even move it in 2D, which is also possible, but we just maybe prefer 3D. So let's show buildings. Buildings of what? I mean, it's a it's a big globe. What I just did here, clicking this button and showing buildings, it's a very big scale. I was just asking Cesium to show me buildings of the whole world. You know, I'm stressing this platform. So let's just go to London, because this is where I'm at right now, and this is where the data is focused on. So let's get those buildings up. And there's a lot of different building providers, this building data providers. This one by default, what are we seeing here? Okay, I'm gonna refresh. I think it was rendering the buildings multiple times when I asked for it first while I was away on the globe, and then it overlaid on top because I just kept clicking that show buildings, show buildings. So let's just stick at King's Cross and ask for buildings in this area. It will take a bit of some time before they load in, but these are 3D models. This is a 3D environment already, overlaying on a real 3D map simulated. So we can pan around. We can go to places. So we can move. Okay. So we have the buildings. We have the buildings. Now we just want to see these tube lines. We can go to different parts. We can go to other different parts of the world to see these buildings. I might have said show me the buildings because my focus is in here in London, but my guess is everywhere else has the building right now. So let me see. Let's go to, I'm trying to think of a place that would have buildings. Let's go to New York. Somewhere in New York, I don't know where, and let's see if we have buildings there at this point. Yeah, so these buildings are rendered across the whole globe. I guess I was just impatient earlier on when I just kept clicking on that show building button. I don't know where exactly in New York this is at. I was expecting to be in a place with high buildings like this. I've never been to New York. Let me just go back to where I'm at. So it was that easy to get these buildings in here with this one function that has 3 lines of code, which some people can make as 2 lines of code. And it's just one feature in our visualization. So the buildings are from OpenStreetMaps, and we're using this OSM building async function. So Cesium, the module within Cesium is calling this function from OpenStreetMaps to just give us this building data. And it's just a lot of data exchange happening between these 2 connections. So we have the buildings. Now we want to make use of the processed data that we have worked with in our Jupyter notebook. This process data is the last bit of what we will work on before we get this what we want to do. So going back to what we're trying to build, we now have the buildings in gray. I think there are ways to customize it. I'm not sure. I know there are ways. If you add shaders in there, write a bit of code, you can customize these gray OSM buildings into any color you like. In fact, you can use a different building provider. You could use Google photorealistic tiles, for an example. It's not as customizable, I think, as this one. That one I tried to work with on my Cesium certification project. Yeah, it was just nice to see that I could render the Google photorealistic tiles in buildings and other parts, but doing something on those tiles, maybe adding shaders or what, it was impossible for me at that moment. I haven't tried again to see if it's actually possible or not, But we're using OSM for visualization, and I'm gonna ask for just maybe, Stephen, I don't know how long do people normally take for breaks? Is 5 minutes okay? Just so I can refill my water. And then we continue adding the tube lines, and then we will wrap it up.
Yeah, that's fine. I'll keep watch of the chat and all that while you're doing whatever you need to.
Okay, thanks. Okay, is it fine if I close my screen? I'll be back soon. Just
All right. See everyone in about 5 minutes. Thank you so much.
thanks a lot. We'll be back in 5.
Oh, we can see your screen and that you're going over LinkedIn.
Hi everyone. Sorry, I left my screen open and then I waited a bit playing around with it. I wasn't aware people can see that. Yeah, I was catching up. So before I continue, are there any questions? Let me look at the Q&A. With what we've done so far, is there anything I need to answer to before we continue? Okay, if no questions, then we will continue. I'm hoping everyone can see my screen. We will continue with trying to see the outline. Okay, we're on part 3, and then we'll go to 4, and then we'll be done. So we've done this, we've got that, we're in VS. Okay, we talked about this data set, Cesium code. Okay, I'll come to this one when we are done with when we're done with visualizing the tubes. So we covered the part about showing the buildings. Now we are going to cover a part about showing the underground lines. In the data from the GitHub repo, there should be this data file that we have been working on, and a couple of geospatial mapping files, and this one in particular is about the transport for London, which we will need to use for visualizing these underground tubes. Let me see, where is this then? Anyways, right, so we have the map showing 3D buildings. We want to get the data that we have processed in a Jupyter Python notebook, our GeoJSON format data. We want to load that data into our Cesium viewer and visualize it. So with this variable, we are accessing this GeoJSON file. We have our function, and in this function, we are loading this GeoJSON data that we have called on here. And then viewer being the container for the map globe, we're adding this data source. So what exactly is this data source? It looks into it. It looks at what type of this GeoJSON file you have, and it just looks through it. And it just looks at each polygon entity that is inside that geo.json file. It wants to get its properties, and it looks at what are the properties of this file. It does find there's a line name in it. And then it saves it in a variable. Okay, there's this file name, and it saves it in a variable, and then this file name has a another property is a line color. You know, a thought comes into mind while I'm reading what the code does, that maybe we should have looked at this geo.json file, because I don't remember us looking at it in full. I remember us just seeing a bit while we we're in the Jupyter Python notebook. But I don't think I have like a nice formatting GeoJSON file viewer that will show all of these features grouped nicely. But this is how it looks. Okay, the ones for the polygons. This is the pre-processed one. I mean, this is the post-processed one. And it has these different tubes, polygons, and it also has their coordinates. So So these are the properties that each tube object has. It has an ID of what a unique identifier for that tube. And it has this property for shared. This basically looks at this one tube station, if it is shared or not. And then the type of polygon that it has, which, as we know, it should be a line. And then the coordinates that it is revolving around. Some of them, they are shared. Like this Piccadilly line in here, it's shared a lot. And it has its own unique identifier. And as you can see, the file is it's a bit big. I mean, relative to, I don't know, maybe other little data folders that I have in here, data files that I have. So for a GeoJSON file, I guess it's normal to have one that is transport data, I mean, one that is of this size. Okay, so we get the value of the line name in these properties. So this is the line name. We get this value here that will be part of the visualization. And we're doing that with this line color, with this line number 41. We go on. We ask for the color of this line, and we define the name colors in here because our data, our process data doesn't have a color property. Programmatically, we assign the colors here based on the line names, which line name is a property we do have in our data source. So we're applying these lines, these colors to the lines, and right in here, we try to zoom into the data source once it's rendered. So let's see how this looks in our visualization. I don't know if I still have it open or not. I'm in the wrong one, am I not? Okay, I don't know. Let me just leave altogether. Poke. Sorry, what you're trying is poking. Never mind. Right, so we want the tube lines. Tube lines are rendering very far. It's the zoom level that we talk that is defined when we're defining the colors. So I'm trying to come closer to them. Here they are. So where is that zoom level? Okay, I cannot really immediately see it. There should be in a way, in a code, where we're bringing the camera closer to where we want to see these underground lines. So different lines, different colors mean a different name of the underground tube. I think if you live in the city, you're probably familiar with, what the colors mean, because the colors in this visualization is coded according to how it represents in real world. So like the red one would immediately translate to central, green for the district, and so on. So now let's get these buildings showing the same time as the colors are showing. And it's rendering slowly. I think I'm still in the Okay, maybe I left. The reason I like King Cross so much is because there are a lot of these lines intersecting. It's a lot of these different underground lines intersecting in one station. So that's why is it King's Cross or just King Cross? I'm not sure. King's Cross. It's King's Cross. Okay, wasn't sure. Okay, maybe not too many, but there's like a variety of them. So this is that visualization. It would be interesting to know, I think, the entire process of how this tube data was collected. But I think the Transport for London has in their website, they give out this data to the public. I think one is to sign in there and get it. Different cities show their transport data differently. We could have visualized the buses instead of the tubes. But because, this was just like a quick way to try and visualize some data, I thought using information that's already available than sourcing it from somewhere else. And they've made it open source probably for this reason, that a community like us can reuse this data and hopefully get some value from it. Okay, so I was so sure that I'll take very long with this visualization, but I did not. We could extend it maybe and add exactly the underground station models if we wanted to. So if we knew where is this station at, we could get a 3D model of that station and place it there where they interact. We could have the line rendering, the names of the stations rendering on top of the lines. That's another possibility that could probably be worth showing. I think they just show everywhere across the city, but yeah, this is the visualization of all the data we have for this tutorial. So different lines showing in a city alongside the buildings. And we can geocode. I mean, unfortunately, these lines, the moment we leave London, they will not be there. But the nice part about it is we can see it differently. So if we just wanted to see it we want to see it with a different terrain map, the colorful version. It doesn't look too bad either. It looks nice. We can do that. That's what Cesium allows us to do, all these different customization. If you wanted a flat 3D map, okay. The rendering has stopped. I have no idea why. So that's also possible. And yeah, I'm gonna stop it here with the code talk and the data talk. I think everyone can see the journey that we took from moving from, not having much data, just like a pre-processed data, to processing it and then bringing it in to be visualized into a 3D geospatial mapping platform. Next, what is it? So yeah, before I take more questions and I close the session, it's deployment. If you wanted to deploy this, I normally use Netlify. I would just go to Netlify right now and drag and drop this this index, this whole folder, including the data and the scripts. Maybe take out the presentation in case it's going to be heavy on the file size itself. This bit, have it as a zip and dump it into Netlify. GitHub pages can also host index.html files, like the static websites. It can host those. The only concern is having that API token showing up. So I'm not going to deploy it on live, just because it is a very basic visualization that it's probably worth showing, but maybe it's worth being refined first before bragging about it somewhere else online. So yeah, so let's go to Netlify and see how the process would be if we did wanted to deploy it there. Yeah, it's a process of creating a new email account, simply because my usual Netlify account uses the old GitHub account, which I have to recover each time I come here to Netlify. They want me to access GitHub first, and GitHub needs some code which I can't get anywhere else. So I hope your situation is different. You can get into Netlify and you just grab that zip and you paste it there, and they'll give you some link, and voila, your visualization is going to be there. Can Cesium display labels for attributes and calculated fields? Okay, I should think so. It has something called billboards. Sandcastle Cesium. It should be. So if I understand the question right, so are you saying with Cesium, could we be able to show the labels of the tubes? Because if it is about the labels of the buildings, then let's just see. We just need to click on the buildings and get information about it. But that's probably not a label. It's just like a tooltip, right? This is not what you mean, is it? There is here billboard entities where you can have fixed labels showing. I'm trying to see that. And this is another great resource. If you ever want to get started with Cesium and you want quick examples to hit the ground running with, this is a website you should spend your time working on. So in this website, you get a whole lot of showcases, how they bring in different 3D models in there, and you get this editor on one hand and the viewer on the other. So like whatever code you would like to put, you should probably be able to see it on the other side almost instantly. I'm trying to find one where they're using billboards, and that's, I think it's labeling. Is this I don't know, change billboard by meter. You mean it like this? Billboard like that? Aldo? I hope I'm saying your name right. Let me see on Bing. Or the labels of the streets, like this one. Okay, let me get it one more time. Yes, I was thinking values and text for each feature. Are we talking about the maybe the buildings feature? If it can show these ones in the buildings feature. It should. I think the question is yes, it should. There's a lot that it can do. This billboard here covers all of it. I was thinking, okay, like the names of the lines. Okay, I think the buildings are embedded in OpenMap. Buildings are embedded in OpenMap. Yes, you're right. The buildings are from OpenStreetMaps. That's correct. Let's go back to our visualization. And then we want to show the tube lines. I don't know where am I and why are they not showing. So it can, but besides it being a Cesium thing, it's more about the data itself. Cesium, remember, it's just like the globe rendering this whole environment that we can visualize this data on. And if I'm understanding you well, you want to have the names of these tubes showing. Here, Cesium, the way it handles it, it's a data source behavior property, where when you click on whatever it is that is a data source to it, whether it's rendered by OpenStreetMaps or it's rendered by you locally or it comes from any other data source, it has its own by default tooltip that, it can return whatever you tell it to return. In this case, it's just returning the ID of the line. This is the central main line. And then if it is shared or not, at this particular station, this line, as you can see, it's the only line, it's not shared. Let's go to somewhere where it is, I don't know, where a line is shared. Let's go to this busy place here. Okay, Victoria is also not shared. I'm trying to see. This metropolitan line here, it is shared. I think this is the purple line in here. So yes, it has. It's just that you need to be sort of thoughtful about how you would like the billboards to show, because there's a lot of movements happening in the 3D space. If you just want like labels at all times, I mean, do you want to have labels at all times or just tooltips to click at a point in time when you want to know more information about the thing you want labeling on? So far, we talk about AR, and thanks for your question. I hope I answered it. If not, I'll do my best to answer it again. You can let me know on the chat. In closing, we've talked about when we open up an example of a project where 3D geospatial map was being used to map an incident that took place at a certain point in time, a certain place, but it was outside. It was outside our buildings. So it's mapping outside using the coordinate system that, the Cartesian planes and the world mapping standards is recognizing. Mapping indoors, it's another challenge at the moment. That even big companies like Google are struggling to get right. It's so hard to map a specific location, a point in a certain building inside it. So there are some ways. I mean, obviously, coordinate systems don't work indoors, or they don't work well. They don't work at all, actually. If you just want to try and see a very specific point, like this office where I'm at right now, in this big building in this Victoria Street, can find Victoria Street and the street name and the address, but inside the buildings, there's no information. Even Cesium doesn't have anything on indoor mapping. So if people know of other good indoor mapping platforms, please let me know in the chat. But where I'm working at, we are looking at creating an application for indoor mapping scenario. Like when I started here, I was getting lost a lot, not knowing which office had what, and this is one example. It's not this is a use case of where it could be used, but it's not our own app. We have a different one that does almost exactly the same thing, if not better. So this app is open sourced somewhere, and the whole point of it is just navigating somebody. Can you still see my screen? I hope so. It's navigating somebody from a certain floor by using area targets. Area targets essentially is how can I say it, an approach in augmented reality or even other types of immersives, where you are recognizing a specific point inside an environment using your device. So this environment, it was scanned. In my case, I scanned the office that I'm working at. It was just to try and build a prototype, not because I was getting lost that first week a lot. No, scanning the entire place and then using the area targets to guide me to navigate inside. So first you use them to locate you where you are. You can ask the app as you scan around to say, where am I at? It will know. As you scan around, it will pick up where you are, your position, it will find it. And then augmented on your environment, that is obviously the real environment, but the augmentation itself, it could just be anything. In this case, we've just seen a bit of an augmentation of a 3D model of an engine. Can't tell exactly what type of an engine that is. So it's a mock data. And here I was just saying, okay, show me where my office is at. And it just tells you, okay, this is the immersion office. And I can search for another place. And I mean, UI could, UI could improve if it was going to be something for the public. It is not. The reason I'm mentioning it is because I was hoping in this audience, maybe somebody knows some work that's really great about indoor mapping, which if you do, it would be great to get in touch and we discuss a bit more about it. Otherwise, we will also launch something around indoor mapping with almost a similar use case. This one, the source code is out in the public somewhere. I've only adapted it for the use case internally. Let me see. So that's enough about indoor mapping. We did outdoor mapping. What is it? What's left? Okay, so going back to our goals when we started, it was just to talk a bit about this 3D data, compared to mapping in 2D, how it is like in 3D. And I feel like we're at the point where we kind of can see that. Understanding how to use Python for 3D geo data in Cesium. Okay, so our geo.json file on its own, pre-processed, it was just 2D, and then we did some processing of it, and then we made it to show in 3D. Python was used in the pre-processing part. It wasn't used in the actual visualization, although you can have Python in Cesium. There's a slide where I've mentioned the reference. In that slide, you can read more. It just has limitations. That's why we're not using it. And yes, I'm gonna close it here. If you'd like to get in contact with me, those are my handles there. And then if you'd like to read about the Cesium certification I did, that's the link in there. And yes, thank you so much for taking the time to join the session. I'm gonna stop sharing the screen.
Yeah, thank you so much for your tutorial, Lilo. I hope you'll be part of future PyData events. And everyone's welcome. Everyone's welcome to continue the conversation in our Discord server. Thanks, Al, for coming.
Okay, thanks. Bye.